All right, so we're here. Let's try to put all this stuff together and actually run through a graph for one of these rational functions. So do f of x is 3x squared over x squared minus x minus 6. We're just going to run through our strategy in order. A couple of these first things should go pretty quickly, and we're just going to run it all down. So step number 1. Check for symmetry. Symmetry, question mark. So that is f of negative x and let's see, if we sub in a negative x, what are we going to get? If we look at the top, what's going to happen, right, is we have 3 times x squared, so negative x squared. That's going to just become, right, back to where we started, positive 3x squared. That could imply some symmetry is coming. We're going to have to see how that compares to what's on the bottom. The bottom is x squared, right, minus x minus 6. If we sub negative x in for both of those, pretty much we can see what's going to happen here is we're going to get, well, positive x squared, but then double negative x is plus x. And just like that, there is no symmetry. Right, so we either need everything to be flipped, or we need everything to sort of come back to where it started. And this is a mix. This is sort of neither, so we're not going to get any symmetry. No big deal. We don't need it. We'll just keep pushing ahead. Next is y-intercept. Just the one, so that's at, right, x equals 0. So we'll just sub that in. So f of 0, so 3 times 0 squared. We almost don't even need to worry too much about this. We're obviously going to get a 0 on top, so that would make everything 0. The thing we really need to check, I guess, more than anything else then is, are we also going to get a 0 on the bottom? If we do, right, 0 over 0, we said that's likely to be one of our holes, right, where we have a gap in the graph. That's not what happens here. We just get negative 6 on the bottom, and so we get y-intercept at 0, so we're going through the origin 0, 0. So that's going to be one of our graphed points. That's going to be our y-intercept. Steps 3 and 4 kind of go together. This is our x-intercepts and our vertical asymptotes. We'll keep this split. So this is top equal to 0 and our denominator not equal to 0. Right, to get an x-intercept, we need essentially both of those things to be true. So the top is 3x squared equals 0. That's going to happen when x itself is 0. We're not really going to talk about multiplicity here. In theory, if you're thinking back to 3.2, and we did talk about multiplicity, I mean, in some sense, x squared, right? That's sort of x and x. So in some sense, this 0 would have multiplicity too. We'll kind of see a little bit what that does in the graph. We kind of know already that this is not going to make the bottom 0, but we should do a check. I'll sort of write everything out as if we don't necessarily know the information from the other steps. So let's check x equals 0 into our denominator. So that's going to look like, right, 0 squared minus 0 minus 6 is negative 6, is not 0. So what we want is to have, right, the top equal to 0 and the bottom not equal to 0. So that's good to go. So that's going to be our x-intercept. Also the y-intercept, right, going right through the origin, sort of to be expected based on what we knew already, but always good, right? We want all these sort of steps to complement each other, and they should all sort of fit together into one nice whole. All right, some of this new stuff, potential vertical asymptotes. So to get that to happen, we need the bottom to be equal to 0, and we need the top to be not equal to 0. So what was the bottom? The bottom for us here is x squared minus x minus 6 equals to 0. This is going to be, right, factor, solve for x. This is a short one, right? This is sort of ABC. The a is 1, so we're really just basing it off of, right, what do I multiply to get a negative 6, and I'm going to add to negative 1. That's going to be negative 3 and positive 2. I'll sort of jump ahead. In theory, right, you could, of course, you might need a few more steps here to sort of make sure you get that factoring and get all that information. I'm just going to jump ahead and assume we're good to go. That's going to get us two different coordinates, right? X equals 3, x equals minus 2. And I'm going to go ahead and box them. We already found the values where the top is supposed to be 0. Neither of them was 3 or minus 2. So those are both going to be vertical asymptotes. Since the top is not equal to 0 at either of them. Right, so in some sense, going through this in this order, if we sort of know the x-intercepts first, as long as we're not doubling up on those same values here in stage number 4, we're going to get the vertical asymptotes, and that's going to be legitimate. Horizontal asymptotes slash end behavior. So again, so we're looking at the two leading terms, 3x squared. Hey, bud, need you to not be on here right now. Thank you very much. Looking at 3x squared over what's essentially a 1x squared, right? The leading terms from both of those things. This is the case where the 2 degrees match. And so what we get is horizontal asymptote at, so y equal to 3 over 1, well, which would be 3. So we're going to get a horizontal asymptote at y equal to 3. Let's try to put all this information together. Step number 6 is we kind of want to make a little table. So this is sort of new, we haven't seen this yet. So we need to plot values between and the x-intercepts and vertical asymptotes. So I sort of need to know values that are between all those things. If I make a little micro table, I'll just shift this up to get ourselves a little bit more space. What I kind of like to do here is, now I know I said, right, we're not really trying to make a table of values here. We're going to do it just sort of selectively. So let's see, what were all our different things? So the x-intercept happened at 0. So we know we sort of have 0 in here. That's going to get us, right, it's also the y-intercept, 0, 0. It's one of our points, 0, 0. That's our only x-intercept. Our 2 vertical asymptotes, so minus 2 and positive 3. So if I do negative 2 here, I'll kind of mark that as a vertical asymptote. I'll do positive 3, mark that as a vertical asymptote. And so what I really need here are values that are sort of between all these points, including sort of out beyond it. So I need to find 4 more coordinates to plot. This is really just to figure out, are we going to be sort of in a positive area that's going to sort of give us a particular shape, or are we going to be in a negative area? Let's use the nicest possible versions of all of our points. Let's just use negative 3, let's use negative 1, let's use positive 1, and let's use positive 4. And so just over here on the side, we'll sort of run all these things down. These should all be defined points. And we should be able to sort of find that without too much fuss. The really important thing here is just whether or not we get a positive or a negative, not so much what the actual number is. Not that, of course, we shouldn't find the number. But again, the most important thing here is really just positive or negative. This would be right. 3 times negative 3 is 3 times 9, so that's 27 over, what is this going to be? 9 plus 3 would be 12 minus 6, 27 over 6. This would reduce down to, what, 9 halves? Or like 4.5, 4.5-ish. I'll call that 4.5 here. We're going to try to make a graph as nice as possible, so we might as well include these points. Sometimes they're just a little too big or too small to really graph all that cleanly. If we do negative 1, we're going to get 3 times negative 1 quantity squared, negative 1 quantity squared minus negative 1 minus 6. This is going to be what? Positive 3 up top. 1 plus 1, right, is 2 minus 6, so minus 4. So negative 3/4. So, okay, right, so the first section of the graph before we get that first asymptote is going to be up in the positive values, right? Positive here. This is going to be negative between negative 2 and 0. Next, between 0 and 3, let's just do positive 1. This should be kind of similar numbers to the ones we just found. 1 squared minus 1 minus 6. So that's 3 on top. This is going to be, right, 1 minus 1 is 0, but then minus 6. So that's going to be negative 1/2. So that section is going to be negative, and then beyond 3, so f of 4, 3 times 4 squared, 4 squared, right, minus 4 minus 6. This is going to be 3 times 16 is what? 48. This is, right, 16 minus 4 minus 6, 16 minus 10. So 6. 48 over 6 is positive 8. So sort of a positive, a negative, and a positive. So that's where we're going to be sort of between all these points. What I'm going to do then, we'll do a part 2 for this, where we actually sketch out this graph, try to put all this information together to make a sketch.